Give me 1 second. Okay. So back to where we were. So you got to, oh, here's this slide. I'll leave it here in case you guys want to write these steps down. Okay. You could pause that if you need to. Examples of what this would look like. All these people are being numbered. All right. Different hotels, I should say. You have the list and it selected these numbers, and that tells you which of your people are going to be used. All right. Also, don't repeat. So if you get any repeat numbers, you skip that one and just move to the next one. Simple as that. Okay. So a lot of these weren't in the list because it only goes from 0 to 28. Since 17 was used 3 times, right? It was only selected once. So if they wanted 4 samples, they're not going to use 5, 16, 17, and 17. You know what I mean? All right, moving on. Okay. An alternative to simple random sampling is called strata. All right. Now, strata does something, or stratified random sampling, where it takes people that are expected to have similar answers or similar beliefs, viewpoints, or even not people, but individuals. Like, say you're doing a study about, I don't know, how different soil affects trees. Okay. Or different food affects animals. And we got a lot of farmers in Reedsburg. Okay. For instance, you might have different breeds of cows. I don't know how cows work. I'm not a farmer. But say you got your brown cows, your white cows, your chocolate milk cows, and your spotted cows. Okay. They might all respond differently to a certain type of food, but they're your population. So maybe you're wanting to test this huge dairy farm, right? And you know that all of them might respond a little bit differently, or they all have different sizes or whatever. They eat different amounts of food, whatever the reason may be. You would put them into their different groups based on their similarities. So you put all the brown cows in one group and you select a random sample from that group. You put all your black and white cows in one group and you select random data from that one. Your chocolate milk cows go in this group. Your strawberry milk cows go in this group. Then you individually take, say we wanted a sample of 100 total. You take 25 from each sample, right? Or each group, or each strata, as it would be called. And then you combine those together. All right. So that would be a strata. With the trees that I mentioned earlier, you would take different types of trees, right? You could have your pine trees. You could have your, what other kinds of trees are there? Oak trees, maple trees, and Charlie Brown Christmas trees. Okay. All your different trees. So those are called strata when they have similarities that you're expecting there to be a little bit of a difference in. Okay. That's different than the next type of sampling. Do I need to touch on this? No, that's fine. I already said that, all that. Now, say for instance, you're going to make a study about soil type or amounts of how much rain affects all these different trees. Okay. But you're just wondering about pine trees. All you care about is pine trees. But different trees are going to get different, what's the word I'm looking for? Effects on them based on where they are. So it's called clustering. In this case, you're going to select a range of objects, individuals in your population that are like geographically near to each other. So not necessarily have similarities, but they're just close to each other. Okay. This is often done in political stuff. So for instance, like certain regions often have similar beliefs. So they'll take individually select a area like Reedsburg, Wisconsin, or Sauk County, right? And they'll pull Sauk County, but then they'll also pull Dane County, and then they'll pull whatever the county Milwaukee's in. Okay. Or Dane County or Jefferson County or whatever, just because there's often going to be similar beliefs in those areas. Or you could say the trees in this area are near a water source. The trees in this area are on a mountain. The trees in this area are in a valley, and they're going to respond differently. Okay. To whatever maybe you have some kind of new drug that you give the trees, or pesticide. I guess trees don't take drugs. Moving on. So those are called clusters. That difference between strata and cluster. Strata takes similarities and groups them by those similarities. Clustering takes geographical location and groups them by that. Okay. Hope that makes sense. And then you individually pull or select or study those individual groups and put them together into one sample. So it would work better that way than just randomly sampling the whole population. Because for instance, if I just randomly sample the whole population, what could have happened, what happens or can happen, and more frequently does, is that I'm not going to get a as many trees that are in the valley as I will in the mountains, right? For one, a valley might have far more trees than the valley or the mountain would have, right? So the odds of me getting a valley tree are much higher than the odds of me getting a mountain tree in my random sample. So now my data is going to be leaning toward showing primarily the valley trees rather than showing what also happens for the mountain trees. So we want to have a even representation or a fair representation going into my whole population, right? It needs to match up. Or just because Dane County might have more people, they're going to get more data from Dane County than you would from Sauk County, right? Things like that are things we have to think about when we're making our studies. And it's things that, like I said, statisticians that get paid lots of money to go and make political campaigns don't do it because they know they can trick people. So we do not do that. We are moral people, at least most of us are, hopefully. Okay, systematic random sampling. Actually, I think, is that where I wanted to stop? Yeah, I wanted to stop there. All right, we will stop there for, well, no, I can do this real quick. It's the last thing. All right. Last thing. All right, last few things that we have. Okay. Let me go ahead. I don't really need the screen for this. Well, I will in case you want to write down definitions. Share screen. Pardon. All right, skip through this. Here we go. Systematic random sampling. Now, in just simple random sampling earlier, we just randomly picked people. Didn't matter where they were in our list. In systematic random sampling, you have a list of people down the list. Say you went alphabetical, and you're just going to choose every 5 people, right? Or every 10, or every 15, or whatever your individuals are. You just choose a number that you're gonna follow, and you go through that list. Okay, it's called systematic random sampling. It can be used as well. It's often used in, like, you guys know what exit polls are? I don't know why I'm again asking you a question when you can't answer, but an exit poll is something that was specifically done a lot back in after you vote for a president or whoever. They ask you a question, not necessarily about who you voted for, but just other opinions. Now, they would often do this, and there's a lot of corruption about this, because what they would do is someone would walk out of the election booth and they'd ask them a question, but they'd like only ask white people, or they'd only ask men, right? Or they'd only ask white men in business suits because they're looking for certain answers. And then they say, oh, we asked 100 people and this is what they all said. So clearly this is how America feels about such and such topic. Okay. So what systematic random sampling does is if you actually want to get an accurate depiction of your population, you say, look, we're not going to allow our brains, because sometimes this kind of stuff would happen subconsciously. There might be certain types of people that you're just more comfortable walking up to and asking a question, right? So you have to actually make sure that you don't even include bias accidentally in your studies. So for instance, systematic random sampling will say every 8th person that walks out of this election booth, I'm going to ask these 8 people, and my population will be the people that voted at this polling location. And I asked every 8th person, no matter what they looked like, who they were, how quickly they were walking, I asked every 8th person, right? That way you're following a system to make sure you aren't accidentally putting bias into your own study. So that's what systematic random sampling can be used for. Now, if, for instance, there may be a pattern in the ordering, the numbering system, then it wouldn't be useful. So maybe, I don't know, people are coming in groups of, like, when they're working or something like that. You might get a lot more people coming between, 4 and 7 p.m., which is going to be like the big rush of people that come to vote right after work. And then you'll have fewer people come throughout the day who maybe are jobless or something like that, and they represent a demographic of your population, but you have fewer of them just because not as many come, right? So your every 8th person is going to be not happening as frequently. So then when you get your data at the end, every 8th person, sure, you followed your sample, but a large majority of those were of a certain demographic, like the working force, right? So you have to be careful about when you want to use these methods, and just really look for any kind of bias in your study. So some things that can go wrong. Under coverage is when a certain group or demographic or just members of the population aren't as likely to be chosen or can't be chosen in a sample. So for instance, choosing your samples or your individuals from like a telephone book and saying, all right, we got our telephone book of Reedsburg and we randomly chose every 10th person. Okay. Well, in that case, anyone who didn't register to put their number in a telephone book or anyone who doesn't have a phone would not be able to be chosen. So there's some undercoverage there. Non-response would be like, I called 100 people, 85 people answered, and you just run your study with 85 instead of 100. Well, in that case, those 15 people that didn't answer they're not represented. That's called non-response, and that's something we want to avoid. Sometimes you can't avoid it just if you can't get those numbers, but you want to avoid it because it can result in bias. Or just inaccurate data. And then response bias is when there's a pattern of inaccurate answers. So, for instance, let me think of something. Oh, okay. Say, for instance, I were to ask you guys how happy your life is on a scale from 1 to 10. You guys might say 7, 8, 9. Joe Schmo says 6. Maddie says 3. Eddie says 1. Carter, he's happy with his life. He gives it a 10, right? Okay, you guys all give your answers. There's no problem there. That's absolutely fine. Next question I ask you, how many dates have you had in the past month? You just answer it. Give 3. Eddie says 0. Maddie says 12. Whatever. Okay. So you give your answers. No problems. Everything's good. Well, now let's rearrange those questions. First question I ask you, how many dates have you had in the past month? You give your answer. No problem. You say how many dates you've had in the past month. Next question I ask you, how happy are you? Well, now your brain is telling you, man, I haven't had any dates in the past month. Maybe this makes a little more sense when you're in college because that's like the whole focus of your life, apparently. But now you're like, man, I shouldn't be very happy. I don't have any kind of love life whatsoever. I'm a 4, right? That just the way you order questions creates response bias. So now, rather than getting an accurate feeling of how happy people are in this class on scale from 1 to 10, just because I asked a question before that resulted in you guys changing your answers, I'm now getting inaccurate data. Okay. And there's lots of ways response bias can come into play, but it's just when you get response bias because of a certain kind of pattern. So even the way you ask a question, like I said, asking someone if they care about safety on the streets earlier, if that results in a inaccurate answer for the next question, then you're getting response bias. Okay. All right. I think that's all for today. Oh yeah, that's pretty straightforward. I don't know why I didn't remember that from before. All right, so that's all for 4.1. I'm not sure how long this ended up being. I think it was longer than I planned. So I might break this up into 2 lessons, might just shove it in 1. So we'll see. Hope you guys understand. If you have any questions, let me know. I will post your work for the day, including like any kind of check your understandings like you guys do in class and your at-home homework. But yeah, that's 4.1. This is like an 11 lesson chapter. It's a big chapter because 12 to 15% of the AP stats questions are on this chapter alone, which is far more than any other individual chapter. So enjoy. Bye guys. See you later.